Maybe I don't know my position and my velocity, but I know my acceleration. Maybe my acceleration at some time t is just a constant 8 units per second squared, right? So I'm going to accelerate at a constant rate. Now, is that enough information to determine my velocity? We have to think back to how velocity and acceleration are related. Well, by definition, right, acceleration is the change, so the derivative in velocity, right? Acceleration is rate of change in velocity. Or in other words, right, velocity is an antiderivative of acceleration. So I know that a of t is 8. Let's now solve for v. Okay, so a of t, my acceleration, is just a constant function 8. And v of t is the antiderivative of my acceleration, right? If I antidifferentiate acceleration, I'm going to get velocity. It means I'm antidifferentiating 8. Well, what antidifferentiates to 8? Well, 8t plus some constant c. Duh, it's that constant again, right? Knowing my acceleration doesn't determine my velocity. It only determines my velocity up to some constant. I could be going really fast or really slow, but still accelerating at the same rate. Well, in any case, I've at least got a formula for my velocity with that constant. Now, can I use that formula to determine my position? Same kind of game. My velocity is the rate in change in my position, right? My velocity is the derivative of position, and that means position is an antiderivative of velocity. So let's antidifferentiate. So p of t is an antiderivative of my velocity, and I figured out my velocity a minute ago. My velocity is 8t plus c. So I want to antidifferentiate 8t plus c. Well, that's an antiderivative of a sum, so it's the sum of the antiderivatives. And what's an antiderivative for 8 times something? Well, that's a constant multiple, so it's 8 times the antiderivative of t plus an antiderivative for c. Now, 8 times, what's an antiderivative for t? Well, one of them is t squared over 2. And what's an antiderivative for c? Well, c times t is an antiderivative for c. And I should add some constant here. I'm going to call that constant big D. Right? So here's my position. I guess I could write this a little bit more nicely because the 8 and the dividing by 2 simplify a bit. I could write it as 4t squared plus ct plus d. Well, that's kind of weird, right? Why are there 2 constants in my answer? Just knowing that my acceleration is 8 units per second squared doesn't tell me my initial velocity, right? This quantity c here is really v of 0, right? It's my initial velocity. And I could be accelerating at a rate of 8 units per second squared, but starting with any of a range of possible initial velocities, right? I could be going really fast at first or really slow at first, but still always accelerating at 8 units per second squared. So knowing this doesn't nail down c. Similarly, just knowing my velocity doesn't nail down my initial position, right? This d here is really p of 0, right? If I plug in t equals 0, I just get d. And that means that d is really providing my initial position. So if I know my initial position and my initial velocity and my acceleration, then I can nail down an exact formula for my position. I can get rid of these mystery constants. The important lesson to take away here is that antidifferentiating can actually be useful. Antidifferentiating lets us take, say, velocity information and produce the position data. Or even better, in this case, it let us take acceleration information, figure out the velocity, and then take that velocity information to figure out my position.